going to try to wait out the wind every time a gust comes up. So we just looked at synthetic division of, if you had an expression where you had to divide one polynomial by a linear function, right? All we're going to do for synthetic division is look at the denominator. Use synthetic division when the denominator is a linear function. That means x to the power of 1 in the denominator, right? So we already looked at a couple examples where, we're taking a polynomial, any polynomial in the numerator, it could be at any order, divided by a linear function, right? Now, if you get any higher degree in the denominator than a linear function, we're just going to use straight up long division, polynomial long division. So we're not going to really be concerned about using synthetic division for doing long division, right? We're just going to use the long division to do long division. What we are going to use synthetic division for is to factor polynomials that are higher order than degree of 2, which is what we want to do, right? What we're working towards. We've talked about all the other factoring techniques. Now we're down to the last one. But, one of the most powerful, really, because it allows us to look at functions that are higher degree than the degree of 2. They're more than quadratic functions. Now we can do that. There's special cases where if you have two things subtracted from each other, you could use the difference of squares to factor them, right? But that's going to be rare if you're going to get, x to the power of 8 minus a number or something else. Just two things subtracted from each other. So synthetic division is going to give us a lot more power to deal with much larger functions. What synthetic division does, it allows us to tackle much larger polynomials, higher order polynomials, and polynomials that have multiple terms in them, right? And if you recall from, the previous series, polynomial is anything in the following form.
You've been fantastic, and I hope you enjoyed it. There is a point. Is there a point to all this? Let's find a point. Is there a point to my act? I would say there is. I have to. The world is like a ride at an amusement park, and when you choose to go on it, you think it's real, because that's how powerful our minds are. And the ride goes up and down and round and round. It has thrills and chills, and it's very brightly colored, and it's very loud, and it's fun for a while. Some people have been on the ride for a long time, and they begin to question, is this real, or is this just a ride? And other people have remembered, and they come back to us, and they say, hey, don't worry, don't be afraid, ever, because this is just a ride. And we kill those people. Shut him up. We have a lot invested in this ride. Shut him up. Look at my furrows of worry. Look at my big bank account and my family. This has to be real. It's just a ride. But we always kill those good guys who try and tell us that. You ever notice that? And let the demons run amok? But it doesn't matter, because it's just a ride. And we can change it anytime we want. It's only a choice. No effort, no work, no job, no savings of money. A choice right now between fear and love. The eyes of fear want you to put bigger locks on your door, buy guns, close yourself off. The eyes of love instead see all of us as one. Here's what we can do to change the world right now to a better ride. Take all that money we spend on weapons and defense each year and instead spend it feeding, clothing, and educating the poor of the world, which it would many times over, not one human being excluded, and we can explore space together, both inner and outer, forever in peace. Thank you very much. You've been great. I hope you enjoyed it. London, you're fantastic. Thank you. Thank you very much.
So as we talked about in series 3a, polynomial is anything in the following form where you have f of x, a function. Now f of x is just generic, right? You can make it h of x, q of x, whatever you want, right? So you have f of x is equal to a sub n, xn, blah, 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 blah. Now, we talked a lot about this from in Series A, right? There's 3 videos out there talking about what a polynomial is, where the A terms are just anything from we're functioning the real number set, right? So the A terms are anything from the real number set. They're just basically coefficients, constant coefficients. And n, the power is anything from the natural number set, or the whole number set if you think about it, because x to the power 0 is just 1. So, you can think about it as n being the element of the natural numbers or element of the whole numbers. So, what we are going to use synthetic division for is to factor polynomials. Any polynomial. Try to factor any polynomial. And what we're going to do, our purpose for this is going to be take these polynomials and try to reduce them down to quadratics, to x to the power of 2, right? Because as soon as we reduce it down to that level, we can use all the other techniques we've talked about, right? We can use simple trinomial factoring, complex trinomial factoring, and the quadratic formula. So when we're given a polynomial that is a higher degree than degree of 2, we're going to break it down, take out as many x's as we can, right? Until we reach a quadratic, and then from there we're going to use our quadratic formulas, right? Or our factoring techniques for factoring quadratics. Now, the way synthetic division works is when we're given a large polynomial, we're going to have to take a guess as what a possible factor of the polynomial is going to be. And the guess that we're going to make is sort of a calculated guess. The guess that we're going to make is going to be possible factors of the constant, the last term. Okay, so what we're going to start off with is possible factors of the last term, and if those don't work out, then we're going to use possible factors of the last term divided by possible factors of the coefficient in front of the highest power. Okay, so I'm just going to lay this out so it makes more sense. It makes more sense visually than it does when I state it. Okay, so the factors that we're going to look into of how to factor a large polynomials are going to be possible factors of the constant, of the A0 term. So possible, we're not just talking about the prime factors of it, we're talking about all possible factors of it. So if this number here was 8, the possible factors of 8 would have been plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8, right? So possible factors of A0 is going to be plus or minus 1. You're always going to try plus or minus 1 first, right? Because plus or minus 1 are possible factors of any number. So plus or minus 1 and whatever else there is plus or minus the term itself, right? Because the term itself is a possible factor of itself, right? So what you're going to do is try possible factors of this first, and if those don't work, and if those don't reduce our original polynomial to something to the power of 2, then we're going to try the possible factors of this guy divided by possible factors of the coefficient in front of the highest power. And the possible factors of that one are, again, it's going to be plus or minus 1 and whatever else plus or minus an, whatever the coefficient is here, right? And you get into fractions once you get in there. Now, possible factors of that guy are just that guy divided by plus or minus 1. So the way you can think about it is, it's just the possible factors of that guy divided by possible factors of that guy. So let's move down and do, one example, and then from there you'll see how it works out. So if you're given a polynomial, what we're going to do is take the last term, the constant term, and the first term in the coefficient, the highest degree, and the possible factors of that polynomial are going to be possible factors of the last term or the last term divided by the first term. I'm going to explain this further when I write it down, okay? So if we have some kind of polynomial in the following form. So let's say we had a polynomial in the following form. Negative 2x to the power of 5 plus 3x cubed minus 5x plus 6, okay? Now if we're going to try to factor this polynomial, Now, this isn't to the power of 2. We don't know any techniques to be able to factor this yet, right? The only thing we can use is synthetic division. And the way we're going to use synthetic division is we're going to take a guess as to what terms go into this polynomial. And the guesses that we're going to make are possible factors of this or possible factors of this divided by possible factors of this. So the first terms, now there's a lot of choices for this, right? But what you're going to do in general, what you're going to do and the questions you're going to get in exams and your homework assignments are going to be ones that work out, right, initially, with the lowest terms. So possible factors of 6 are going to be plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6, right? How you doing? Are you going to use this one or the other guy?
I like to use it all, probably.
Yeah? Okay, I'll be like 10 minutes? Okay, sweet. So possible factors of this polynomial are going to be plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6, or these guys divided by possible factors of negative 2, which is plus or minus 1 or plus or minus 2. Now you don't have to write down plus or minus 1 or plus or minus 1, because all of these guys just divided by positive or negative 1, it just flips the signs and it's just the same terms, right? So it's possible factors of, you know, the ones that are higher, right? Forget about the 1 term, so it's going to be plus or minus 2. So what we're going to try initially is going to be a combination of these guys. And, you know, obviously we're not going to go with the highest number first. We're going to start off with the lowest numbers and we're going to try some of these out. And once we start doing a few of these, we're going to get a pretty good idea of which one of these is going to start working. Okay, so first thing we would do is try positive 1, and then if positive 1 didn't work out, the remainder wasn't equal to 0, we would try negative 1, and if that didn't work out, we move on to positive 2, negative 2, positive 3, negative 3, positive 6, negative 6, and if none of those works out, then we're going to try the fractions. Now 1 over 1 is just going to be 1, and all these guys, the 1 here is just the terms, right? So we already tried the ones divided by 1. So the next terms we would try out would be plus or minus 1 divided by plus or minus 2, which would just be 1 over 2 and negative 1 over 2. It'd be, 2 over 2 would just be 1. We already tried those ones. And the next one would be 3 over 2 or negative 3 over 2, right? So you just continue on from there. Now, we're gonna do this slowly, right? So what we're gonna do is not factor this guy. We're gonna take a smaller polynomial and try to factor that one, okay? And from there, we're gonna build up to more complex stuff like this. We'll go find another wall. There's a lot of skaters here. We're gonna get out of here. So we'll take it from there, okay? But we're gonna start off slowly and build up to something like this, okay?